Hello, I'd like to welcome you to today's Makino Experience Center, or EC. This is what you've responded to. It's introducing a compact vertical machining center for high volume production, and we're going to talk specifically about the Makino Slim3n. Little housekeeping item while we're here, you'll notice down in the lower right hand corner there's an area for questions or messages. So while we're talking today, you could go ahead and type in any kind of message or any questions you have and send that, and we'll try and address as many of those as possible at the end of the presentation. My name is Bill Howard. I'm the product line manager for vertical machining centers here at Makino. I'm actually in Makino Mason facility. We actually have two experience centers here. Experience Center number 1, where I'm coming to you from, and Experience Center number 2 down at the end of the hall. We also have two experience centers at our Auburn Hills facility in Auburn Hills, Michigan. So I just wanted to basically provide you with that information. And by the way, while we're talking about experience centers, if you want to follow up on anything you see today, or you have a project you want to talk to us about, we can use these for a private one-on-one meeting directly with you. So that's one of the advantages of the Experience Center. What we're going to do today, we already said we're going to talk about the Slim3n. So there's actually two versions of it. There's a pallet changing version, and there's a table version. And this is what they look like. This is the pallet changer version here. You can see with the pallet changer doors. And this is the slim table version. Now, we could stand here and I could talk to you about this, but why don't we walk out in the shop? Just so happens about, I don't know, 75 feet down the hallway here, we have those machines. So let's take a walk out there. The machine on the right is the table version machine. Just so you understand, the yellow item there on the front, that is the light curtain. There's also a striker switch there on the right, as you can see. Now, we're not going to show you into the machines. We've got some customer work that we're doing, so we want to honor the proprietary nature of that. There you can see on the side, this is the pallet changer. There was a door on that side. There's a door on this side. Obviously, with the pallet changer from the front of the machine, you can't see into the work zone. The control is on the side too, obviously, so you can basically access the front for loading, unloading parts. There's also, you'll see there, some additional controls. That's for hydraulically actuating fixtures. So those are actually the machines, and I apologize. We could go into the work zone and show you more, but we don't want to basically give away what we're working on there. So, and like I said, if you have a project, we can literally meet in here and work back and forth with you on the machines on the floor using the Experience Center. Let's talk a little bit about how the machine is built. This is the basic structure of the machine. As you can see, the carrier is on the top of the machine. Basically, the spindle moves side to side for x-axis. The carrier moves front to back for the y-axis, and obviously up and down for z. So x, y, z, all of those travels, as you can see over here, on the top of the machine. You're looking at 35 millimeter linear guideways for x and z, and 45 millimeters for x and y, and 45 millimeters. Oh, I was right the first time. Sorry. You're looking at 35 millimeters for X and Z and 45 millimeters for Y. The ball screws are all 40 millimeter. So that gives you an idea of the basic construction. Again, X, Y, and Z all above the work zone. Now, it's a one-piece column and bed structure. It offers enhanced stiffness and rigidity, outstanding dampening. It allows you to have high speed without compromise. The axis dynamics are not subject to change based upon the fixture size, the component weight. You get very good consistent motion and speed and very good precision because the work is on a stationary table. This is actually on the shop floor. It's kind of looking at it from two different corners. This is the bed and column. So you can see here's kind of from the right front, and this one is from the left front. Here you can see the linear guideways are already on the machine. That would be for your Y-axis, moving front to back. Here we've completed a lot more of the machine. Here you've got, again, Y-axis, the X-axis, left to right, and then the Z-axis, up and down. And this shows the table. Again, the table is fixed. All the axes move relative to the table. How big is it? Well, 500 by 400 by 400, X, Y, Z. So basically 20 by 15 3/4 in Y and Z. Now the neat thing about the machine is if you look at it, it's less than 5 feet wide, and it's 16 feet deep. Now, you say 16 feet. Give you an idea, that's the width of this EC display in the front of the room here. And that includes the coolant tank, lift-up chip conveyor, and chip buckets at the back of the machine. So it's a very compact machine, which means you got a lot of productivity and a very minimal floor space. As far as standard configuration for the table version, 600 by 400 table, 881 pounds, 400 kgs, and about a 32-inch load height. Now we offer an optional table, and you'll notice it's longer. It's 900 by 400, same weight, about the same load height. And you might say, well, why would you offer the optional table? Well, here's an example of how that longer table would allow you to use a rotary workhead and a tailstock so that you could put a part in there and get multiple side access to that particular part. Just to give you an idea, here is that larger table with a tilt rotary table, and it happens to be a Niken on it. So here you'll see a tool change. We're going to come in and work on the face. Then we'll index the part, and we'll work on the top surface of the part. We'll rotate it, work on another side of the part, that's side number 2. Index it again, that's side number 3. And here's side number 4. So in one setup, we've machined on 5 faces of that machine. Now, the key thing about that is obviously it minimizes setups, number 1. Number 2, reduces your cycle time, your amortizing, your rapids, and your positionings. And number 3, it's going to enhance your precision or accuracy because all of those features are all machined within one fixturing. Here's another example. In this case, it's kind of tough to see, but there's actually 2 workpieces there. We're working on the top of both workpieces. And then there's a tool change again. And then we'll come out and tilt the workpiece down, and now we can work around the sides of the workpiece. So, again, 5-face machining on small parts. Let's talk about the pallet changer. Pallet changer is 500 by 380. The 500 is side to side. The 380 is front to back. And that 380 is determined by, you'll notice it's a arc by the rotation of the pallet changer. The weight, 127 to 200 kg. Well, how can it be? Well, the critical thing here is inertia. So the weight, depending on where the weight's at, creates different inertia. So that's why you could have up to 441 pounds, depending where the center of gravity, center of mass is on that weight. 810 millimeters, so about, again, 32-inch load height. This will pallet change in 4.5 seconds, plus or minus 10%. So it's very quick. Here, this is the limiting factor, the diameter. You're looking at about 1,200 millimeter diameter, and you can see that's determined by the door opening for the pallet changer. And this happens to be a rotary workhead, and on both pallets, but let's give you an idea here what that would look like. This is a pallet changer, and you'll notice it's got a vertical rotary table and tailstock on both pallets. So we have multiple side access. To give you another look at that, this is 5-face machining or multi-face. Here we're going to flip the part over. The tool change is going to go to its neutral position, so we're out of the way for the pallet change. There's the pallet change. So now we have the part that was on the stalker is now in the work zone. We're going to change tools to a face mill. We can go in and we can actually work on multiple sides of that part. There's a face mill. Now we're going to come over and change to a drill. And again, we could work on multiple sides of that part. So it's amortizing all your tool changes, all your positioning rates down over that multiple setups. And it's single setup, so less handling, shorter cycle time, and again, the accuracy of putting all those features in the single setup. Let's talk about how fast is this machine. Well, you're looking at rapid rates 50 meters a minute, so basically 2,000 inches a minute. Feed rates 20 meters a minute, or 787, 800 inches a minute. Ack and deck, again, side to side is X, front to back is Y. 1.1 G, up and down for Z is 1.5 G. So obviously getting in and out of the workpiece, so it's quicker. Now, we took a lot of effort and studied into the spindle characteristics. And we compared most competitive machines. You're looking at either a BT or a CAT, and we've gone to HSK. And the reason being, you'll notice with the HSK, you're loading on the side, plus you have face load. So your connectivity and rigidity have two faces versus one. Your tool change repeatability, very good because of this technique. Tool holding security, very high, again, because of the HSK technique. High-speed applications, very, very good. Again, you have face contact, more stiffness, more rigidity, less run out. And obviously run out, you have high run out over there. Here on the HSK, very low. So we made the decision going in, HSK A50 is the interface and the tooling that we're going to use for all of these reasons. Another reason, if you look at traditional BT, CAT, SK, you're getting a fair amount of run out. Well, run out, not only is it bad for surface finish, but it's bad for tool life as well. So you see, once we get into the HSK range, we have significantly longer tool life. Again, that gets into economics. You're going to spend less money on tooling, you're going to get more parts per tool, and a higher quality part. So let's talk about the spindle. Standard is a 50 to 16,000 RPM, HSK A50 we just talked about. 20 horsepower to 15 horsepower. You're looking at 26 to duty to 14 continuous as far as the torque. 55 millimeter diameter, 2.16. Your grease packed bearings. 0.7 seconds, so less than a second. 0.7 seconds plus or minus 10% to get from 0 to 16,000 RPM. So very responsive. Here you can see the red is the power curve. The blue is the torque curve. So out into about 4,000, you're getting your max, your constant torque. You're increasing power. You have constant power from here all the way out to 16,000 RPM. Obviously, you're losing some torque, but you still have very good torque all the way through the RPM range. Now, I've toned these down from a noise standpoint, but this is cutting in steel. This is a 45C so 45 Rockwell C. And you're looking here at about 105 cc's per minute. So very good, stiff, rigid milling machine. 1530 RPM, 300 meters per minute feed rate. Now, what about aluminum? Well, here's an example in aluminum. This is 6061. Again, it's a lot of coolant, so that gives you an idea of the capability of the coolant on the machine. But again, you're looking at 1200 cc's per minute metal removal rate in that aluminum. Now, as an option, if you're going to be into more difficult to cut materials, cast iron, steels, that kind of thing, we offer an optional 8,000 RPM HSK A50. Same kind of horsepower, 25, 15 continuous. But look at the torque, 60 duty to 25, so more torque. Grease pack, 55 millimeter diameter bearings. Now, with the lower RPM, you're 0.4, less than half a second, plus or minus 10%, to get from 0 to full 8,000 RPM. Once again, here's the red is the power curves. You know, you lose a little bit way out here, 7,000 RPM. Here's the torque curve, and you'll notice much more torque, almost twice the torque as the 16,000 RPM spindle, and very good all the way out through the RPM range. So a very versatile but very rugged machine. Here's another example. This happens to be a face milling 45C steel. Now this is a rather long, I don't know if you can hear that growling in the background, but this is a milling machine. It was designed to do face milling and large drills and end milling, and it just so happens, because it is a vertical machining center with good milling capabilities, obviously we can drill and tap with it as well. So when you look at the capabilities of this machine, not only is it a good milling machine, it's an outstanding, because of the dynamics and kinematics of the machine, it's an outstanding machine for drilling and tapping as well. So you'll see here, I want to hang on till it starts coming back the other way, because it throws some really nice chips out there. So unlike a lot of the competitive machines, this machine has the guts to do heavy milling and then obviously drilling and tapping as well. Here, this is the cut coming back. So you can see the chip peeling off here along the side. So that's the 8,000 optional spindle that's available for the machine if you're into that kind of material. What about tool changer? Well, the tool changer is a disc right here. There's 26 tools there. It's armless, direct pick and exchange. So basically, as the spindle, and you've seen a couple tool changes already, as the spindle comes back, it will deposit the tool in the magazine, go on up, the magazine will rotate, and then the spindle will come back down through and pick up the next tool. So it's very quick, very efficient. The other thing is, in this middle image here, you'll see this sheet metal. That is the ATC shutter. That's what prevents chips and coolant from getting back into the ATC magazine. It literally rotates with the magazine. So there's not a lot of limit switches and proxies and all that. Very quick, very efficient. Let's talk about characteristics. I said 26 tools. All pockets full, you're 80 millimeters in diameter. Adjacent pockets empty, you're 140 millimeters in diameter. 320, over 12 inches long. Tool weight, 7.7 pounds. Tool moment, 1.77 foot-pounds. And down here, speed, efficiency, which drives down cycle time. You're looking at 0.8 seconds tool to tool. Less than a second. Chip to chip, 2.8 seconds, and that's T1, T2. So that's if the tools are right beside each other. Obviously, the worst case would be if you had a tool number 1 and we're going halfway around the disc to get the tool number 14. and then you're looking at about 3.5 seconds, and that's chip to chip. You've already seen a number of tool changes, but I feel I should show you one more. You'll see it go over, go up, and come back. So it goes over, deposits the tool in the disc, goes up, the disc rotates, it comes back down, grabs the next tool, comes over, and goes on to the work. Positioning, accuracy, precision repeat of the machine. Standard, 5 microns plus or minus. Positioning, repeatability, 3 microns. As an option, we can equip the machine with scales and basically cut those values in half. 2.5 micron positioning plus or minus, 1.5 micron repeatability plus or minus. So an extremely precise, very accurate machine. Some of the other topics talk about chip and coolant and all of that kind of additions. There's a 400-liter, 105-gallon chip and coolant tank. There's a lift-up chip conveyor in the center that basically the chips go in at the front of the machine, come back through the disc, and out the back of the machine. Nozzle, flush coolant, ATC cover wash to keep chips from getting down on the top of the ATC, and through spindle coolant is standard on the machine. Here's kind of a better picture. Here's the nozzles around the spindle. Here's the through spindle coolant. So you can see those, and then there's overhead wash, part wash, and then there's flush down the walls, kind of a terrace wash down into the chip and splash guard, which is down in the throat and goes back through. You'll also see that everything is directing or mitigating the chips to go right down into that center lift-up chip conveyor in the back. Again, over there, you're looking at nozzle coolant, flood coolant, through spindle coolant. Here's some of the wash coolant. This is the flush coolant. And then here again, through spindle coolant, 3-point MPa or 430 psi. And that's got a cyclonic filtration as well. As far as operator friendly, obviously the control is right there with an easy touch. The operator can be loading and unloading tools directly to the spindle. And the loading height is anywhere between 29.5 and 31.9, so 32 inches depending on whether it's the standard table, the optional table, or the APC. Another thing, it's maintenance friendly. You notice how narrow the profile is. Everything's collected at the back. You have your chip and coolant tank, your pumps. This is your high pressure tank here for through spindle coolant, your cyclonic, and then here's your lift up chip conveyor and discharge. From front to back, overall is 16 feet, and that's including lift up chip conveyor. So very short, very narrow, very high productivity, and a small amount of floor space. It uses the Makino Professional S control. What's back in behind there is the FANUC OIMF control. It's a LCD 8.4-inch color screen, touch screen, 4-axis simultaneous, 4+1 capability. Lots of memory. We've equipped the machine with lots of memory, lots of programs, lots of tool offset pairs, and the ability to DNC or use USB port to get your programs down to the machine for typical production environment. Turnkey and automation support. We've thought through and have designs. The design on that side of the screen, basically the left side of the screen, is for the table version machine. The right side of the machine is for the pallet changer down through the center of rotation. You'll notice that there's hydraulic fixture, air seat check, fixture blow, fixture and coolant wash, and auto door. Let's talk about automation. Obviously, you could have a manual walk line where the operator walks from op A to B to C, or you could put a loader in front there, or again, a robot or some type of dedicated load unload. You can have a robot on a rail or a movable robot. And then over here is like a fixed robot where there's multiple machines arrayed around the machine. Let's give you an idea of what some of these automation would look like. This happens to be, believe it or not, a clutch housing. That's a pedestal robot loading it to a Slim3 table version machine. This is a very similar type application, pedestal robot. You'll notice there's two parts in there, and this is a rotary workhead with a tailstock. So here we're going in, robot grabs the two parts, puts the finished parts in the rack. It's going to come up and grab two green parts. It's going to take them in. They're going to be clamped. And we're off to go. And you notice there were two parts there, so it's handling dual parts. Now, I don't know if anybody just was at EMO in Italy for 2021. It was like the first week of October. But we wanted to show the Slim with some automation there. So here's a kind of a schematic of the cell. You notice it's an A-B load, so they're taking the A part and moving it over to the B fixture. They're actually doing some washing and air drying of the part before they bring it out. There's an in-feed and an out-feed conveyor as well. This cell also has some optical inspection of the part. So that's just to give you an idea. Here's what it actually looked like on the show floor. Here is the cell as we're getting ready for the show. And obviously the picture over on the right, that's some traffic through. It was very popular. And again, it gives some perspective with the people in the picture. Very compact, not a lot of floor space, but the ability to have very high production volume. And then here's a short video. You're going to see the robot, the gantry robot coming in, and it switches parts. It actually then takes the part and washes it into the coolant, then comes out and it's drying it, and then it'll bring it down and put it on either the outfeed conveyor. One's in-feed. Obviously, that's the in-feed. Here's the outfeed. And as I said, there's actually some optical inspection in this particular cell as well. Moving on to a much bigger cell. This happens to be a cylinder head, aluminum cylinder heads. There's 6 machines on 2 sides of a rail. So there's actually 12 machines there. Each machine has an A-B load. There's 6 setups, and there's 36 tools. And basically the takt time, if you will, is about 5 minutes. So every 5 minutes we're getting a finished cylinder head off of this line. And you can see it's got overhead gantries, in-feed conveyor at this end, out-feed conveyor at the other end. So this is where you can go. And keep in mind, you can start with a single machine. You can couple machines with a hand walk line. Then you can automate that. You can go to a rail. And then eventually you can build up to an installation like this. That concludes the official formal presentation. I'd like to throw it open to questions, and we'll take a look and see what kind of questions have come in while we've been presenting here. Yes, thank you. While we were talking, I apologize. I had to put my glasses on so I could read the questions. But a couple questions have come in. One of them was a question about professional S control. What is that? Well, the key thing to remember is the base control is a FANUC OIMF. That's got a lot of capability. It's one of the most popular controls in the market. And ladder logic for allowing us to interface to automation, robots. What we've done with the Professional S is that's a Makino-esque front end or GUI interface that allows us to make that seem and operate and function a lot like the professional versions that we have on our other machines. There was also a question about spindle. There's actually two different spindles there. The standard is a 16,000 RPM, 20 horsepower, 15 continuous, about 30 foot-pounds of torque. As an option, we can configure the machine with an 8,000. It's still 20 horsepower, 15 continuous, but what happens is we kick the torque up to about 60 foot-pounds. So, and the other thing to keep in mind is these machines were built from a milling machine perspective. So obviously a good cutting capability for milling. Obviously, if they can mill, they can drill and tap as well. Another question was about scales. The machine, we purposely did not configure the machine with scales. When you think about some of the high production parts, the tolerances may not necessarily require scales, so we didn't put scales on a standard. In lieu of scales, we've actually put a coolant temperature controller on there. We felt it'd be more important to keep control of the temperature of the coolant, and therefore it washes down over the part in the machine. However, scales are available as an option, and actually we can put them on either X or Y or Z or all of them together. It's an optical glass scale, Heidenhaus. They're manufactured, they're called Mori, which means they're glass, and we're actually counting fringe interference patterns. So that's as an option, you could configure the machines with scales. There was another question here about tools. It's 26 tools is standard. So there is no smaller capacity. The question was about smaller capacity. So, and looking, give me pause just a second here till I refresh and just make sure that something hasn't come in while we're chatting. I don't see any other questions that have come in. I've addressed all the questions that are here. So at this point in time, I'd like to thank you for joining us today to discuss the Slim, and hopefully we've met your needs. Remember, we have these experience centers. If you have a project or something you want to, machine you want to discuss, project you want to talk about, we have the ability to provide you with personal, confidential, proprietary, back and forth, just like we've done today here on this Experience Center. So again, thank you very much for joining us, and hopefully it was beneficial, and you'll have a very good rest of the day. Thank you.